A huge thanks to my Patreon supporters for making this episode possible. Good morning, fellow mathematicians! Welcome back to another video. First things first. I finally started off with calculus over on Flammable Maths 2, so if you want to see more calculus-based content, go over to Flammable Maths 2 and subscribe there. Link to the videos will be down there in the description, info box, pinned comment, etc. It's improvised session time today, and I found this problem over on Facebook, mathematic memes, as a meme, as the name would suggest. And guess what? On the thumbnail, or on the meme in itself, there was my boy, Fresh Toad Walker. And this problem has been proposed probably by Fresh over on his channel. I haven't watched his video, as always. I do not enjoy his content in the least, but I'm going to solve it because it looks kind of clickbaity, and probably title and thumbnail of the video are just going to be the same as what Fresh did over on his channel. So some more ironic clickbaiting here. And we're going to dive right in. I hope I can solve everything. And yeah, we're going to see how it turns out. So what's the problem exactly? We get this given, so the multiplication of two factors equal to 1. That's already important, I think. And we want to find out what x plus y squared actually is. And first thing that came to my mind, if we have a multiplication of things being equal to 1, in the real numbers, that would suggest that both factors are equal to 1, so 1 times 1 is equal to 1, or one factor is the multiplicative inverse of the other one. So meaning x plus blah 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 is equal to 1 over this factor of y. Okay, and we can put both cases into one case because the multiplicative identity, so 1, if both factors were equal to 1, they are already multiplicative inverses to one another, meaning we can pack both cases into one main case. Namely, if we were to divide by this factor under the condition that's not equal to 0, we are going to get that x plus square root 1 plus x squared is equal to 1 over y plus square root of 1 plus y squared. And yeah, first thing that really comes to my mind when I see something like this is to rationalize the denominator in some way. I think this does make the most sense here, and for this we can use difference of two squares. This is just something that you are doing so often in analysis. If you want to do epsilon delta proofs for something square rooty, 1 over square root of x, for example, see if the limit works, for example, you are going through this process in some way. So you are going to see this a lot in analysis-based proofs, also in calculus, etc. What I mean by this is we are going to expand this fraction by y minus square root of 1 plus y squared over the same thing. And I hope you can see where I'm going with this. Okay, if we were to multiply those two together, this is going to be the difference of two squares, obviously, leaving us with y squared minus, and then this factor here squared. Meaning overall what we are going to get is, I'm going to write everything out, so 1 times this is just y minus square root of 1 plus y squared. And I think this should work out, and then difference of two squares down here is going to give us y squared, and then negative this square root squared is going to be negative 1 minus y squared. And this is good, you see, I mean rationalizing the denominator is good because y squared is going to cancel out, and then we're going to get this part over negative 1. Meaning we can just distribute negative sign into here, meaning overall that x plus square root of 1 plus x squared is hence nothing but square root of 1 plus y squared minus y. And this is what we are having right now, which is good, which is really good. We are looking for x plus y squared overall. Why not add y on both sides and subtract this square root on both sides, leaving us with x plus y being equal to this square root minus the other square root. And then we can square both sides and see where all of this is going to lead. Okay, that's equivalent to saying that we have x plus y being equal to square root of 1 plus y squared minus square root of 1 plus x squared. And like I said just now, we are looking for x plus y squared, what this is going to evaluate to. So let us square both sides. And let's see what we're actually going to get. I mean, on the left-hand side, this is just a binomial theorem, leaving us with x squared plus y squared plus 2xy being equal to, okay, this squared and this squared is going to give us 1 plus y squared plus 1 plus x squared. This is cool because this and this are going to cancel out overall. And then we're going to get a negative sign 2 times square root 1 plus y squared times the square root of 1 plus x squared. But this factor is really ugly here. I don't know where we are going to get this one from. We are going to see how it turns out. So at first we are going to subtract those on both sides, leaving us overall with 2xy being equal to 1 plus 1 is 2. Oh, this is good. So 2 is 2 times 1. I'm going to write it out like this. It's more apparent in a second. Minus 2 times square root stuff. Square root 1 plus x squared. We can factor out 2 on both sides. We can factor it out and then cancel on both sides. This is good. Now we are at the point where we have x times y being equal to 1 minus square root stuff. Okay. There should be a way to simplify this more. Can we get the x times y from... I mean, we can get... Oh, that's not even too shabby. If we were to multiply all of this out, we are definitely going to get x times y, what we have here, and also those square roots will multiply together. Let us write everything out here. So from the first equation, we are going to get that, if we were to multiply everything out, we are going to get x times y plus, okay, then square root 1 plus x squared times the square root of 1 plus y squared, and then plus x times the square root of 1 plus y squared plus y times the square root of 1 plus x squared. And all of this is equal to 1 exactly. Let me subtract 1 on both sides, then all of this minus 1 is equal to 0, which is really good, considering that we have x times y. If we were to add this on both sides and then subtract 1 on both sides, we are going to have x times y minus 1 plus this is equal to 0. And we actually, that's this part, and subtracting 1, all of this is 0. This is simplifying quite nicely actually. We are going to get that x times 1 plus y squared plus y times square root of 1 plus x squared is equal to 0. This is really good. This is really nice. Now we can subtract this on both sides or the other one, meaning we are going to get that those two are nearly equal, just with a negative sign. Now we can square both sides, leaving us with x squared. Square root is going to vanish here. X squared 1 plus y squared is equal to, and negative sign is going to vanish once squaring both sides, and y squared 1 plus x squared. That's even nicer. It's going to simplify more. That's equivalent to saying that we have x squared plus x squared y squared is equal to y squared plus this is nice. Great conclusion here. Okay, this is going to cancel out on both sides. And we are it can't be this trivial, right? Okay, we are going to have to do more casework, but the conclusion is already pretty nice. We're going to get that x squared is equal to y squared, meaning if we were to take the square root on both sides, we're going to end up with absolute values. Absolute value of x must be equal to absolute value of y. We have to consider two cases now, in my opinion. We are looking for x plus y and the whole thing squared. So the first case for the absolute values could be that x is equal to y or negative x is equal to negative y. This really doesn't change the casework, okay? Because we are taking the squared here. So the case one is that we are having x is equal to y, or we are having negative x is equal to negative y. It's the same because we are going to get, just as a side note, either we are going to get x plus y squared, or if we were to consider this, it's going to turn out to be the same thing, because negative x minus y and the whole thing squared, you can factor out the negative 1, is just going to be x plus y squared yet again. So for our purpose, this really doesn't matter. Okay, now we need to see, I mean, plugging this into here really doesn't change anything. But what we can do is we can plug this into here probably. Then we are going to get into equation number 1 that 1 is equal to x plus the square root of 1 plus x squared and the whole thing squared. If we were to plug those conditions into here, or at least one of those, then we're going to get this factor squared, obviously. Then overall we are going to get that, okay, that's equivalent to saying, I'm going to write everything out. 1 is equal to x squared. Then this is going to be plus this factor squared. This is going to give us plus 1 plus x squared. And then plus 2x square root of 1 plus x squared overall. Oh yeah, 1 and 1 is going to cancel out on both sides. So this one right here is going to die. Then we are going to get 2x squared overall. But the 2 is not equal to 0, so we can cancel it out on both sides. Leaving us with x squared plus x times the square root of blah 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 is equal to 0. But this is a factor of two things, because we can factor out the x on both terms. Meaning we are going to get x times another factor is equal to 0. Now we can have two cases. Since we are in a field, we can have that either x is equal to 0, so x is equal to 0, or we are having that this factor is equal to 0. X plus square root of 1 plus x squared is equal to 0. But this right here is not possible. This shouldn't be possible because the square root, yeah, how should this be possible? Even if this x were some kind of additive inverse to this part, it couldn't be the additive inverse because square root of 1 plus x squared should be overtaking this. Let us subtract this on both sides, like x on both sides, I really don't care. Then we are having that negative x is nothing but square root of 1 plus x squared. If we were to square both sides, then we are going to get x squared is equal to this right here. Yeah, it doesn't work out. There is no x value satisfying this equation, meaning our x is equal to 0. But since x is equal to y, or negative x is equal to negative y, really doesn't matter, we are going to get that y is equal to 0 too. Meaning overall, x plus y squared is going to be 0 plus 0 squared is just 0. So this is for the first case, and now we shall see if, no, that's basically it. Last case we would need to consider is for the absolute value of x being equal to the absolute value of y. It could be that, for example, negative x is equal to y, because taking the absolute values on both sides wouldn't change anything. So the second case is that x is equal to negative y, and if we were to plug this into here, then we are going to get exactly x plus y is nothing but x minus x overall. This is 0 squared and this is 0. Meaning, in each and every case, it's probably 0, and I hope this does it. Yeah, as always, improvised session, and I can just hope that everything is correct here. There was actually a fun little problem. There's probably an easier way to do this, in some way. I don't know, probably using like a total differential in some way. There's probably an killing way to do something like this, but it was a lot of fun. Fresh, I give it to you. Fun problem. Thank you guys for watching. If you enjoyed this video, please like, subscribe, and comment, channel if you like. Don't forget to check out the Improvised playlist, linked down there in the description. Also go over to Flammable Maps 2. Naked leg, oh, that's sexy. Go over to Flammable Maps 2 and subscribe there. Calculus over there. Also buy those sheets I created, support channel on Patreon. Until next time, have a flammable day. Ciao.